back to Small Caps. Today I'm speaking with Managing Director of Altech Chemicals, Iggy Tan. ASX code is ATC. Now, they've got a lot of news coming out this week and lots of growth. And so I've asked Iggy to come on because a bit of a game changer going on with the company. So I want you guys to sit up and take notice. They have been doing some innovations in the space, the high purity alumina space. And we all know that we're going into the green technology. So Iggy, great to see you. Thanks for joining me on Small Caps today.
Thanks for having me, Kerry. Nice to see you again.
Always good to see you, my friend. Look, for those of our subscribers out there that may not know who Altech Chemicals are, can you give us a brief overview of the company?
Yeah, Altech Chemicals is focused on high purity alumina. We've got a project at the moment where we extract kaolin out of Australia and we ship it to Malaysia, and it's a chemical process to make high purity alumina. We're in the final stages of project finance, but more excitingly, we're now taking that high purity alumina technology and going downstream closer to the lithium-ion battery industry. So our coating technology coats graphite material and silicon material, and we intend to have that as a product to the lithium-ion battery industry.
How's that going to work? I mean, we all know about lithium-ion batteries, but what's the connection between what you guys are doing and the lithium-ion battery? Just give me a better understanding of how that's actually come about.
So today, I guess the lithium-ion battery, the future of lithium-ion battery, as Tesla has set up in their vision, is to have more energy density in lithium-ion batteries. And to do that, Elon Musk has said that they need to have more silicon in the anodes of the lithium-ion battery. So silicon is a very promising anode material. Why? It's because it has 10 times the energy density compared to graphite. So for a layperson, just imagine the 10 times more sites that the lithium can sit on in silicon as opposed to graphite. Now, if this material is such a promising anode material, why isn't silicon in commercial lithium-ion batteries today?
That was going to be my question.
Yes, basically there are two major problems. Silicon expands 300% in volume and it fractures during the performance of the battery. And the second problem is that it absorbs about 50% of the lithium on its first charge, and it's actually called the first cycle loss. And imagine grabbing 50% of your lithium in the battery and making it inactive. So because of these two problems, the industry have been trying to resolve it in order to get silicon in commercial batteries.
And what's your breakthrough to get that higher, the higher density or the higher energy that is required in these batteries? Because it has been an issue.
Yes, so we've been working on this for 12 months now, and essentially we think that we can resolve this problem by coating silicon or graphite with a very thin layer of alumina. It's about 2 nanometers, a very thin layer. It doesn't stop the lithium ions from going through it, so it allows the battery to perform, but it stops that, maybe the fracturing, and it also stops that first cycle loss. It stops the lithium from being absorbed onto the silicon particles. So we feel that it resolves those two issues. And this week, we will announce that we have been successful at cracking the silicon code. We have now managed to make lithium-ion batteries at 30% higher energy density than conventional lithium-ion batteries. So imagine a normal lithium battery, with 30% extra energy density, because we have now used our coating technology to incorporate silicon in anodes. And we have done this in our laboratories in Perth. We've now got into batteries, making the batteries. And what's the most important thing, Kerry, is that you get to the batteries and you cycle the batteries and you go through the performance of the batteries to prove that it actually works well. And so to get a bit technical, a normal lithium-ion battery has about 330 milliamps per hour per gram. That sort of reflects the energy density. our batteries are running at around 430 milliamps per hour per gram, which is a nearly 30% increase in energy density. And this is really a game changer for the lithium-ion battery industry. We're very excited about that. And we're looking to go to the next phase where we improve further than the 30%.
Oh, further than the 30% you've already got. But
Yeah.
what I want to know is two things. One, is it protected? Is there a patent around this technology?
Yes, we have patents on our technology itself, and all our work is done in-house. So it's the know-how is kept in-house, and we have been working under the guidance of our chief scientist, Dr. Jinwan Lui, and in the last 12 months, essentially cracked the silicon code.
Is that what you call it, cracking the silicon code?
Absolutely.
I'm sitting here listening to this, and when you said it's 30% at the moment, but we're looking to go even more, that this is patented technology.
Yeah.
Have you reached out to companies like Tesla and the likes and some of these battery operators and said, listen, we think we've cracked the code here? First of all, Iggy, sorry, how did you crack the code?
Well, essentially using that alumina technology and coating the materials, and as I said, it resolves that. Now, partnership, I guess we have collaboration agreement with a German group called SGL Carbon, one of the largest graphite producers in Europe. We also have a collaboration agreement with Ferroglobe, one of the largest silicon producers in the world. So essentially, we buy the graphite, we buy the silicon, we use our technology to coat it and then put it into an anode material product. And we've started pre-feasibility on a battery materials plant in Saxony in Germany. So we're very focused on commercialization. We're not a research and development company. We're more on commercialization. This feasibility study will be about 10,000 tons per annum of battery materials in the state of Saxony in Germany. And the reason we have proposed to build this plant in Europe is because our view is that the battery story, or the lithium battery story, will be about Europe in the coming decades. I guess it's fair to say it has been about China, Japan, and Korea, but we think the focus will shift towards Europe, and really driven by CO2 emission standards. I'm sure you know that all the car manufacturers in Europe have announced that they will go all electric by 2033, and they're spending billions of money to get there. So consequently, something like 600 gigawatts of battery building capacity have been announced in Europe. Companies like CATL, Tesla, Samsung have all announced battery production in Europe. And the EU has said that they don't want to rely on materials coming outside Europe. They want everything to be produced within Europe to supply that industry. Now, I think you asked a question about partners. We can only say that we have an NDA with 2 German automakers, and we have an NDA with a battery producer in Europe as well. So they have been tracking our progress, and we'll be working with them to get these into electric vehicles.
Because that has been the challenge, hasn't it? Because it is the storage of energy, but it's not just electric vehicles. I would imagine batteries are everywhere. So this technology is not just for EVs, it's across, I guess, home batteries and all sorts of things, wouldn't it?
Absolutely. It can be applied to all sorts of areas that batteries are being used. But the focus is really electric vehicles, because it really gets the cost of electric vehicles down. And if you can have 30% extra energy in a battery, you can imagine that you can just downsize the battery and give you the same distance in an EV. And that really brings the weight of the car down and the whole cost of the car down. And so many people in the industry have been trying to solve this silicon issue.
Iggy, is there anyone else doing something similar to you? Because to me, I'm sitting here at the moment chatting to you. I've known you for a while, Iggy. This is massive. And so I'm thinking, have you cracked a code that no one else can crack and it's patented? So, this is literally such a big game changer, not just for Altech Chemicals, but for the world.
Yeah, I guess there are people that are dealing with this sort of things, but they tend to use very expensive materials. So they call it nanosilicon particles, very minute particles, and the cost to get there is very expensive. So yes, there are nanoparticles that work today, but they're not economically efficient. Our process, we are able to incorporate silicon in the anode at very economical prices. So that's the key to it.
It's all, at the end of the day, it does come down to economics and making things more affordable. What's next for Altech, and what's the sort of environmental side of this as well? Because we all know that COP20, whatever it was, has just finished, and there's all this focus on ESG and the green environment. How does Altech fit into that as well?
Yeah, that's a great question, Kerry. As you know, our HPA project has been accredited as a green project because our technology doesn't use aluminium metal as a feedstock. So there's about 49% less greenhouse gases to make 1 ton of HPA. We're going through the same process with the battery materials plant in Germany. We have identified the green credentials of this plant. Essentially, it reduces the CO2 footprint for lithium-ion batteries. So essentially, if you have a high energy density battery, you are going to reduce the CO2 footprint. And we're in the process of going to get this plant accredited with a leading group called Cicero out of Norway.
Oh, yeah.
And we're looking for green credentials or accreditation for this project. And downstream, we will probably then be able to access the green bond market when we finance the project.
Well, that's before we wrap up, because we're running out of time. Iggy, let's talk about funding and next steps. What are you looking at? Are you going to be able to get some governments around the world to help fund this? Because it is a game, as we said right at the beginning, this is a game changer for not just the EV, but the whole battery markets as a whole.
Yeah, so the next phase is, as I said, to move beyond the 30%. To complete the pre-feasibility study, we'll be also looking at funding a pilot plant to get this material into testing with the downstream customers. And at the moment, we are looking like it's a very exciting project, and all the hard work that our chief scientist has done is paying off. And let me assure you that this is a very significant milestone, and we've said a great breakthrough for the industry.
Well, I think it is. And look, Iggy, it's been fantastic to chat to you, because what great strides Altech Chemicals have made. And as I said, I'm actually quite excited for you, because that was, I guess, the real challenge was, how do we make this more energy efficient, more energy dense? So it sounds like you've cracked the code. But Iggy, I like to finish off my interviews with this, and that is 3 reasons, because this is an investor audience, Iggy. Why should people be sitting up and taking notice, investors that is, of Altech Chemicals ASX code ATC right now?
Thank you, Kerry. The 3 reasons. Number 1 is that we're involved in high purity alumina that has high demand in the LED and lithium-ion battery industry. So we've got a project that is well advanced. We're the final stages of project finance. We've already completed stage 2 of the construction. So we've got an ongoing project. Number 2, we have another project that is moving downstream to the lithium-ion battery industry. As we mentioned, very exciting breakthrough in creating 30% higher energy density batteries, which then eventually would lead to a battery plant in Europe. And thirdly, the market has acknowledged the progress of the company. And I guess in the last 12 months, we've tripled our share price, and we're looking forward to the future of these 2 projects.
Well, Iggy, I have to say, well, first of all, thank you for your time, but also congratulations on two very significant projects. I'm very excited for not just the HPA, but this downstream game changer for allowing battery car makers to just turn around and say, listen, this will be more economic. So I wish you all the best. Perhaps we should talk again in the near future as this comes, because there's a lot of news coming out of Altech Chemicals right now. So thanks for joining me today.
Absolutely. Thank you, Kerry.